but it's a passive element which will be storing the charge and which will be storing the energy in the form of like electrical energy. To control the variation time scales in a circuit, we'll be using this capacitances. If you want the faster circuits, you'll be using the smaller capacitance. Or if you want to control the time lagging, if you want a time lagging for the signal to be moved, if you want one particular signal has to reach another point at one particular time, like t is equal to 10 seconds, it has to move. Then if you use a capacitor between the two modules, that will delay the signal, so that within that time the signal which has to reach to the second module will be reached. So that's how it will be used for controlling the timing scale in order to vary that one, or in order to slow. It will be used as an intermediate between the 2 points. So this is a diagram where you're having a two points, two charges here. These are the two conductors which are been isolated electrically. Two charges, charge plus and negative charges, where electrically these have been isolated from each other and their surrounding to form this capacitance. So now here, in the previous slide, I have drawn two metal parallel plates. So these two parallel, assume that there is a parallel plate which is parallel, which is like vertical here. Assume this is a vertical plate, and this is another vertical plate. So now here in this, on this particular plate A, a positive charge has been settled. On this particular plate B, a negative charge has been settled. That is the meaning of this. This will act as a capacitor. When the capacitor is charged, the charge on the conductors or the plates, as they are called, have a same magnitude Q. Both will be having the same magnitude Q, but opposite in sign. But they will be in opposite in sign. So in order to make the capacitor, or in order to make that particular charge to be stored, you are supposed to use in between a dielectric, so that the charge will not be nullified between the two positive and negative plates. So that's why we use a dielectric material between these two plates, which acts as an insulator between the positive plate and negative plate. So coming to the capacitance, how this happens to the capacitances. So see now this diagram which is shown here, there are two plates which are in parallel. These are the two plates which are in parallel. Between these two parallel plates, even your layers also looks like this only. There are two plates which are in parallel. The first one is a bottom one, like it has been taken as a negative plate, and the top one is taken as a positive plate. And this is the distance between the two plates, like D is a distance, and V you can see the here one. So now it is a voltage difference, that is the potential difference. So now here, this is a previous, it's an explanation to the previous diagram how an electric field lines have been formed, and movement of the field lines between the two plates, positive plate and the negative plate, where A is the area of cross section of this particular plates. So now here we are having two parallel plates made up of two plates of area A separated by a distance of D. Now the charge on the facing plate surface has the same magnitude Q. Both will be having the same magnitude Q and Q. It means like it will be having like 4 coulomb plus 4 coulombs and minus 4 coulombs. You'll be having the same kind of this one. So now it will be like if you talk about the charge, 4 coulomb and 4 coulomb will be there, but it will be opposite in sign. So that's regarding the same magnitude but opposite in sign. As a field line shows, the electrical field due to the charge plate is uniform. It is uniform at the central region between the plates, and the field is not uniform at the edges. The field will not be uniform at the edges here, as indicated by the fringes of the field lines here. You can see this one. Here you will not be having a uniform electrical field, but whereas in the center part you will be having the same uniform electric field, which I even studied this one in the basics of BEE, like basic electrical engineering subject, and also in the physics. Now here let us see some what is the formula for the capacitance. We know that the formula for the capacitance is Q equal to CV, where C is a capacitance, Q is a charge, and V is a potential difference. So now if this potential difference, if I write it as C equal to Q over V, I get the capacitance of that one. C is equal to Q over V is a capacitance, and the unit for this capacitance is 1 farad. 1 farad equal to 1 coulomb over 1 volt. So you get 1 farad equal to this, a unit of capacitance, 1 farad equal to 1 coulomb per volt. that is equal to 1 C by V. So this is a small formula regarding the capacitance, how to calculate the capacitance while doing some analog calculations with respect to the circuits. Now, charging of a capacitor. How to charge this capacitors? We know that in order to charge the capacitor, we need the switch to be closed. If the switch is closed, then only the signal will be moved from one point to another point. So now here in the first case, the circuit is incomplete because here the switch is open. Because the switch is open, it will not electrically connect the wire attached to the capacitor. So whenever the switch is closed, if you close this particular switch, then there will be an electrical connection between this capacitor and the battery and also this wire. Then only the charging will be takes place in this capacitor in between the two plates of this capacitor. If the switch is closed, the electrical connection connecting those wires and the circuit is complete, charge can flow through the switch and the wire. Through this particular switch and wires, the charge will flow in order to store in this capacitor. As the plates become oppositely charged, regarding the oppositely charged, I have given a lecture in the previous classes how the opposite charges takes place. That is due to the process called an induction method. Due to that induction process, one plate will be having a positive charge, and other plate is having a negative charge. If you want, you can visit that particular lecture. You can look into that lecture in my YouTube channel, Capacitance. So now here, until it equals the potential difference V between the terminals of the terminals of the battery. So now here, as the plates become oppositely charged, the potential difference increases until that potential difference is equal between these two battery plates. With the electrical field is equal to 0, there is no further drive of electrons. Whenever the electrical field is equal to 0, then definitely what happens? If field is equal to 0 means there is no motion of the electrons. If electrons moves from one point to another point, only we can say there is some electricity has been developed or electric current has been developed. If electrons are not moving, then we cannot say that. We can say that there is no electric field. The capacitor is then said to be fully charged with a potential of V, and Q is equal to charge equal to Q. It means, I want to give a real-time example. Now, if you're trying to charge your mobile phone or if you're trying to charge your power bank, whenever the power bank is fully charged, the current from the particular socket will not enter into your mobile phone or into your charger. It will be completely charged. Since a capacitor is fully charged, it will not allow furthermore charges to enter into that one. So that's why, then what happens? If you put that one in the same way, then what happens? The charge will slowly try to discharge from the particular capacitor. And also some people, what they do is that even though if your mobile phone is turned off while charging, and even if your laptop is turned off, and still if you try to put that plug into that socket, then definitely the charge from that capacitor will discharge through that wire to the low potential area. That takes place. So you should always make sure that once if your capacitor or your battery or your laptop or your mobile phone is fully charged, you're supposed to remove the plug and make sure that the discharging of your battery will not take place. So that's what has been mentioned here. If a capacitor is fully charged, there will be no flow of electrons whenever that is the switch is on. If a switch is off, what happens? The reverse process takes place. The charge will slowly discharge from high potential. Now this becomes a high potential and switch is open. So now here, this point will become as a low potential. When you try to switch off, there will be no supply from the socket, so or from the battery or from a power supply region. So that's why that region will become as a low potential area, and the capacitor or your mobile phone battery or your laptop battery will become as a high potential area. So there, due to that difference, the charge will flow from capacitor to the this one. So that's why you should be very careful while taking care of that one. Once if a capacitor is fully charged, you should remove that plug. So this is a formula how to calculate the capacitor. Calculation of the capacitance has been done. This is for a non-uniform motion. This particular equation integration part has been done for a non-uniform motion, where Q equal to E into A, integration of Q into E into A, and therefore Q equal to epsilon naught EA. And this is a difference between the two potentials. VF, there's a final potential and the initial potential. We have studied one formula. V is equal to integration of E ds. That formula is nothing else but E equal to V by D, which is a formula for electrical potential we have studied in the basics. So from that formula, you will be writing this one, Vf minus Vi equal to integration of E into ds. If you apply the limits for this one, ultimately you will come across a formula called V equal to Ed. V equal to Ed and E equal to V by D. So this is the formula for, now you substitute this one in the other formula which you have seen, like C equal to Q over V, and those formulas, if you substitute, ultimately you will get the formula of C equal to epsilon naught A over D. And this is a formula for a capacitance in order to find out with respect to the parallel plates. In order to find out the capacitance with respect to parallel plates, if you're having a parallel plate of area A and the distance between the parallel plate is D, then this is a formula to find out the capacitance. And the previous one is a formula in terms of charge and the potential difference. And E is epsilon naught. We know this value for the epsilon naught, 8.85 into 10 power minus 12 Coulomb square per Newton meter square.